and welcome to Maths with Mr Amison. Today I'm going to be talking about multi-step problems involving Pythagoras theory. This is where you have more than one right-angled triangle in a question and you have to try and figure out a missing length in that question. Before you watch this video, I would recommend watching how to find missing lengths using Pythagoras theory by watching this video here. So to start, I'm going to go through the example on the left and then I'd like you to have a go at the example on the right. So on the left hand side, I'm going to show the working out, follow along, and I'll explain this working out once it's complete. If you need some extra time, please pause now. So you can see that I started by labelling the side length AC as Y. The reason I did that is because I need to find the length X, which is the side BC. In order to do that, because this is a right angled triangle and I don't have any angles given except for the right angle, I have one side here that I know, and one missing side here. So I can't actually find this yet because I don't have enough information, but it links to this triangle here. This line AC links both of these triangles. So if I can find the length AC, I should be able to use that information to find the length BC. So in this triangle here, in the triangle ACD, I have two shorter lengths, AD of 9 and CD of 12. So I can apply Pythagoras theorem, y squared equals 9 squared plus 12 squared. So y squared equals 225 in total, and when I square root that, taking the positive because it's a side length, I get y is equal to 15. Once that is done, triangle ABC now has two lengths that are known and one unknown length. So in this case, you can see opposite the right angle is our 17. Therefore, the length AB is our longest side. So in Pythagoras theorem, C is equal to 17. A would be equal to X or Y, and so would B. I've taken A is equal to Y and B is equal to X. So 17 squared is equal to 15 squared plus X squared, because we calculated already that Y was 15. So 289 is equal to 225 plus X squared. If I subtract 225 from either side of the equal sign, I have 64 is equal to X squared. And taking the square root of both sides, 8 is equal to X. So your turn, have a go at the similar question on the right hand side. See if you can find the value of X. Now you've had a chance to have a go yourself. If we label AC Y, just like I did here, because that links the two triangles, you can see that our unknown side that we're trying to find this time is the length CD. And again, this triangle has only one side length given and a right angle. So we need to find the length that links the two triangles first. You can see in this top right triangle, this time we have a large length here, longer side opposite the right angle of 17. Now we have our other two shorter sides, and we can apply Pythagoras theorem in this triangle because we have a right angle. So C is equal to 17 because it's the longest side, and A or B is equal to 15 in triangle ABC. If I then square those numbers, I get 289 is equal to y squared plus 225. Subtract 225 from both sides, I end up with y squared is equal to 64 and y is equal to 8. Which means that this triangle ABC is the same as this triangle ABC, only the 15 and the 8 have swapped sides. So if this side here is 8, then that means we have two pieces of information in this triangle and we can find the third. So in this triangle, our longer length is y, because that is the length opposite the right angle. So y squared is 4.8 squared plus x squared. And we know our length y is 8. So 8 squared is 4.8 squared plus x squared. So 64 is 23.04 plus x squared. You can use a calculator for that. If I subtract 23.04 from either side of the equal sign, I get 40.96 is equal to x squared. And x is therefore equal to 6.4. I'd like you to have a go at these 6 questions. Now, question 5 and 6 are trickier questions. They are using trickier aspects of algebra, so if you struggle with those ones, that's okay. They're there for a challenge. But as you work through these, try and spot what's similar and what's different between each question. Have a go. So here's the answers to the questions. For the first question, you can see that we have the hypotenuse of this side and the shorter side of this triangle. On this question, I haven't changed any of the numbers. But this question actually ends up being impossible because the length here would be 15, and that should be our longest side because it's opposite our right angle. However, we have 17 here, which is meant to be a shorter side, and 17 is not shorter than 15, therefore that question is impossible. For question 3, we have the triangle ABC, which we can use to figure out the length AC, because that AC is the common side between the two triangles, and then we can use that to figure out the length of AD, which ends up being 9. Question 4 has completely different numbers, 6, 2 and 7 around the outside, completely different to this one. However, the answer ends up being the same. We still get the length of x being 9. Question 5 is tricky. We have to remember that when we square the 2x, we end up with 4x squared, and we have to find the length AC before we can find the value of x. Question 6, we have to use expanding double brackets and a bit of quadratics if we want to be able to do that. If you struggled with those last 2 questions, that's okay, don't worry about it. They are there to challenge you. Okay. So thanks for watching. Speak to you soon.